Alright, in the last section here, chapter 5.3b, we're going to look at conditional probability and we're going to add the idea of independence on it. Two events, A and B, are independent if the occurrence of one event does not change the probability that the other event will happen. Alright, so what does that mean mathematically? Well, we say this. If A and B are independent, then A given B is equal to A. Is the probability the same as just A? The probability of B given A is equal to the probability of just B. So basically you're taking off the condition. If the probability of a conditional is the same as when you take the condition off, then we say the two events are independent. Now this is another way of saying it. It's more complicated. But I just always remember if you take the condition off and they're equal, then they're independent. The probability of one event does not affect the other. Alright, so let's look at this in terms of that example we did in the previous video about the baseball teams. We had winning and tacos, if you recall. So the probability of getting tacos was 30 out of 81. Okay, 6 or more runs is what that meant. But the probability of getting tacos, given that they won, was 26 out of 41. Okay, and the probability of getting tacos but not winning was 4 out of 40. Okay, not winning. So what does that mean? There's differences in all these, right? So if I take off the condition of winning, it is very different. The probabilities are very different because does winning affect whether you got tacos? It has something to do with it, right? They had to get 6 or more wins. So these two things, or this would show us that these are not independent. It's more likely to get free tacos if they win. Therefore, they're not independent. So really all I would have to show is the probability of tacos by itself and the probability of tacos given winning show that these two are different. And that's enough to show they're independent. This third one is just kind of bonus evidence. All right? So let's try this one. Is there a relationship between gender and relative finger length? To find out, we used a random sampler at the United States Census at School website to randomly select 452 U.S. high school students who completed the survey. A two-way table shows the gender of each student and which finger was longer on their left hand, index finger or right finger. So go ahead and pause the video and check to see which one's longer, your index finger or your right finger on your left hand, or are they the same? Okay, my index finger is longer, just FYI. So let's look at this. Are the events female and has a longer ring finger independent? Justify your answer. So I need to look at those probabilities and see if they're the same. So the probability of my ring finger being longer is 234 out of 452, and that gives me 0.518. Now, what's the probability of ring fingers longer given that I'm female? Well, that is 82 out of 212. 82 out of that given female, 212 is 0.387. So how would I answer this? I'd say these two probabilities are not equal. So the events female and longer ring finger are not independent. Knowing that a student is female makes it less likely that her ring finger is longer than her index finger. Okay? So you could phrase that several ways, but the bottom line is that these two probabilities are different. Therefore, they are dependent events. Alright, the general multiplication rule for independent events. Okay? It says this. Probability of A and B happening is, well, probability of A times the probability of B. Okay? Well, why can that happen? Alright, it's not on the formula sheet. Well, it comes from our conditional probability formula that is on the sheet. Alright? Now, we said if two events are independent, that the probability of A given B is the same as the probability of A, right? So if I just substitute the probability of A in for the conditional statement down here, I end up with this multiplication rule for independent events. All right? That's how we got there. If you know two events are independent, the probability of both of them happening is simply multiplied. All right? So then you might ask, well, what's the difference between mutually exclusive and independent? Well, let's look at some examples. Let's say event A is a red card. Event B is drawing a club. Okay? Well, probability of event A. What's the probability you draw a red card from a deck? Well, half the deck's red, so that's 0.5. What's the probability that you drew a red card given that it's a club? Well, hopefully you remember that clubs are black, not red. So you can't get a red club, so that probability is 0. These two things are mutually exclusive. They cannot happen at the same time. And they are not independent. They are dependent on one another because if it's a club, then it can't be red. So they very much affect one another. Let's try another one. Event A is a red card. Event B is a 7. So the probability of drawing a red card is 0.5, like we stated. Now, what's the probability that you drew a red card given that it's a 7? Well, we know there's 4 7s in the deck. 2 of the 4 are red, so it's 2 out of 4 is 0.5. Now, are these two things mutually exclusive? No, there is such a thing as a red 7, so that can happen. Are they independent of one another? Yes, they are. Look at that. Just because it's red doesn't mean it's a 7, right? And the probabilities mathematically of a red card is equal to the probability of a red card given it's a 7. That just happens to work out, therefore they are independent. Example 3. Probability of a red card is event A. Event B is that it's a heart. Okay, we already said the probability of getting a red card is 0.5. Probability of getting a red card given that it's a heart is an absolute 1 because all the hearts are always red. So these two are not equal, so they are not independent. It is dependent. A heart depends on being red, vice versa. So they are not mutually exclusive, they overlap, and they are not independent of one another. So bottom line, two mutually exclusive events can never be independent. Okay? Can never be independent. If they are mutually exclusive, they can't be independent. It's not going to happen. Let's look at this one. All right, last example for you. The first trimester screen is a non-invasive test given during the first trimester of pregnancy to determine if there are specific chromosomal abnormalities in the fetus. According to a study published in the New England Journal of Medicine in November of 2005, approximately 5% of normal pregnancies will receive a false positive result. Among 100 women with normal pregnancies, what is the probability that there will be at least one false positive? All right, so we have to think through this. So the equation that comes to your mind is that the probability of at least one false positive is 1 minus the probability of no false positives. That means no false positives means they were all negative correctly, okay? So for all 100 women, those all got negatives correctly. That would be 95%, because we know 5% would be the false positives. So 95% were correct. So 95% for each woman up to 100 women gives me this. We can assume that this works because each woman's pregnancy is independent of each other. So then if I take that value and I subtract it from 1, that gives me the probability of at least one false positive with the result of 0.9941. Over 99% probability that at least 1 out of 100 women will get a false positive. All right. What about this? Weather conditions. On a recent day, the Dallas Morning News forecasted a 50% chance of rain in Arlington and a 50% chance of rain in Mansfield. What's the probability that it will rain in both locations? Well, can't answer this because these events are not independent. So if I know if it's raining in Arlington, It probably means it's raining in Mansfield because they're so close. What's happening in one part of the city does affect what happens in the other. So because these are independent, I cannot just multiply, or these are dependent events. I cannot just multiply these two values together. So always read, thinking through, are these two events independent of one another? Because if they're not, you cannot just answer the question by multiplying. You would need to know the probability of one location given the other.